Testing. Testing, 1, 2. Good. All right. So my name is Brian, and I read something good in an old book that I'd love to talk about. There's a book called The Mythical Man Month by Fred Brooks, first published in 1975, that many of you may have heard of. Some of you may have read it. Anybody read it? Anyone? Okay, somebody's read it. Okay, well, you'll still like the talk if you've read it, I think. So I first read this book around the time that I was in college studying computer science. And I need to clip this on here so I don't drag it off the table. I was not very experienced at programming when I first read the book, but I still found a lot of value in it because it is just full of insights about human nature and problem solving and teamwork, and it's really well explained, well written. Highly recommended. It's a really good read. And that's been about 20 years since I first read it. So recently I decided to read it again now that I'm a much more experienced developer to see if I had any more insights that I could get out of it. And I certainly did. There's one in particular I want to tell you about. So there's a part in the book where he's talking about the roles that you divide people up into on large projects, and how on many software projects you have some people who are responsible for designing the architecture and other people for building the architecture to that design, which made sense to me. Even 42 years after this book was written, we still talk about architecture a lot, and we use it in that same general sense. We talk about a monolithic versus a microservice architecture, or MVC versus MVVM, or any of the other ways to divide your front end and back end in terms of architecture. And what we mean is the architecture is the high-level organization of the code, the way the parts of the code are divided up on the highest level to get the job done. That's been my sense of the term architecture, and it fit completely with what I was reading in the book as he was describing it. But then I got to this line where he says, "By the architecture of a system, I mean the complete and detailed specification of the user interface." So I had to go back and read that a few times. The complete and detailed specification of the user interface. Is that surprising to anybody here? That was very surprising to me, because that doesn't really fit with the definitions of those two terms, architecture and interface, as I understand them. I would have told you if you'd asked me that, yeah, those two things are related, certainly, but they're also, in a sense, independent, because you could design two different interfaces that both sort of wrap around the same architecture, or you could satisfy the same interface requirements with more than one architecture. So this was a little bit of a mystery to me. He doesn't really spend any time unpacking this sentence. He just kind of throws it out as an aside, and he goes on. But there are some clues as to where he might be coming from. So for one thing, he's working on operating systems. Those are the kinds of development projects that he was involved in that inspired him to write this book. And if you're building an operating system, especially in 1975, you're going to be extremely limited in memory, space, and in CPU. And you want your code to be as small as possible to get out of the way of the application code that's running on that machine. So you don't have a lot of room in your code for layers of abstraction between your interface and whatever's underneath it. So that could be one reason that in his world, these two things would be more dependent on each other. Another thing to consider is that when he says user interface, he's probably talking about the system calls that the operating system exposes to the application developers on that machine. So he's talking about a completely programmatic interface. So I thought maybe with those two constraints, the very limited system resources and the fact that it's a purely programmatic interface, maybe in that situation, these two things become so dependent on each other that they're essentially the same thing. Maybe that's where he was coming from. So I went on with that thought kind of rattling around in the back of my mind, and I was working on some code shortly after that. And if you'll bear with me for just a second, I'll explain how that code worked. So I had a client, my client, who needed me to make a service to let them submit documents to a third-party online service for processing. And the client wanted to submit these documents in a nice, modern JSON and HTTP interface, whereas the client only accepts XML files loaded onto an FTP server. So that was the whole point of this service, was to take the incoming requests, translate them to the different format, send them on. And that's all it does, but the client needs to get results back also. And they also wanted to get these results back as JSON and HTTP requests, but separate requests that I would make to a callback URL that they have on their system. And there's a couple ways that those callbacks can be triggered. So if I encounter an error processing the document and I can't send it on to the third party for whatever reason, then I can immediately send them back an error message as a callback. On the other hand, if I do send it on and the third party processes the document, they're going to drop some results as a CSV file on to their FTP server. So I need a separate service that's watching for those FTP files that's going to send the callback to the client. Everybody following that architecture so far? And then there's one more wrinkle, which is really funny. If there's an error at the third party, they can't process the document for whatever reason, like our XML is malformed or something, they send us an email. That's the only way that their fully automated system has to communicate an error back to us. So I need a separate service that watches for incoming emails and then sends the result back to the client. So this is the entire architecture. I thought I had a pretty good one. It seems like about the simplest possible architecture to solve this problem and to satisfy the client's desired interface of these HTTP requests in and out. But this architecture was a little hard to work with in some ways. It was difficult to test. I had test code in here to make sure that my JSON responses were correctly formatted. But to test it, I had to trigger all these different code paths. I had to simulate an email coming in to make sure the JSON was right. I had to simulate an FTP file to make sure it was right. I had to go through all these code paths to test this JSON. And another way it was hard to work with was just debugging and observing it running in production to make sure it's working right. Because if, say, the client gets a response back that they didn't expect, where do I go to find out where it came from? I might have to check the email logs. I might have to check the FTP server. There's all these code paths that I have to deal with. So I thought back to what Brooks said about architecture and interface. And I realized that if you look at it in a certain way, my choice of architecture is very limiting in the options that I have for working with the code as a developer. The architecture sort of dictates the things available to me to test the code and to debug the code. So really the architecture forms a sort of an interface to me as a developer, as a person writing test code, as a person debugging things. So there is a sense in which the architecture and the interface are really one-to-one related. And the interface that this architecture was giving me wasn't a good fit for my problem. So what would be better? What would be a better interface? And I realized that there's a concept that's really central to thinking about how this program works, which is the idea of a result. So we've processed the document, and we've gotten some kind of result. Either it's good or bad, success or failure. And we haven't sent it on to the client, but we have that result. That concept is really important to reasoning about how the program works, but it's not represented here anywhere. It's just kind of implicit in all these different code paths. So I changed the program, and I added a table of results, just a database table that can hold any kind of result. Either we process the document, we failed to process, whatever. And now, if I encounter an error on my end, I insert a row in the table. If I get an FTP result back, I insert a row in the table. If I get an email, I insert a row in the table. All the results go into this table. And then I just need one more piece, which is a service that watches for results and sends the JSON on to the client as a callback. So this architecture is easier to work with. It's easier to test because I only have to drop a result in the table in my test code to test the formatting of these responses. These code paths are all shorter and easier to test. It's easier to debug because if the client receives a result they didn't expect or they don't receive a result they did expect, we now have a starting point. Okay, let's look at the results table, see what results we have. That's a starting point for debugging. So this is a better architecture. It's easier to debug, it's easier to test, it's easier to maintain. And this better architecture came from thinking about the interface that the architecture presents to me as a developer. So in a way, Brooks was really onto something that's still relevant. The architecture kind of is the interface in a sense. So my advice to you is read old software books. And if you've already read them, read them again, because if you're more experienced, you're going to get more insight that you didn't get before. Because there may be problems that we're struggling with that great writers have already solved and written down that we're not reading about. So please contact me. Let me know if you end up thinking about this idea and if you find ways that it applies to what you're working on, or if you find ways that it doesn't seem to fit what you're working on. Please let me know. And I love to talk about this stuff, so find me afterward if there's anything you want to talk about. Thanks.